Okay, so what is the template? What's our template that we can use to describe any absolute value function? F of x equals what? Say it again. X minus h plus k, and one other part of that, a out front, right? So it looks like that. Okay, that's how we can describe or graph any absolute value function, just by plugging in values of a, h, and k, right? So let's review for a second how that works. So if I've got, we know that a normal absolute value function, just plain old absolute value of x, f of x equals absolute value of x, just looks like this, right? It's just a v. Everybody remember this? It's just a v with the vertex at the origin, right? Okay, so think what h and k do. What do h and k do to functions? H always transforms a function how? Okay, it translates it right or left, doesn't it? Okay, so let's just say, hypothetically, let's say that for our function that we're going to build, let's say h equals 3. Okay, what does k do? Up and down. Okay, so let's say k equals 2. Okay, then what did that really do? Okay, that took the vertex and it slid it 3 to the right, correct? And up 2? Everybody agree? So here's going to be the new vertex, right? What are the coordinates of the vertex then? 3, 2. How about that? Right, so the coordinates are 3, 2, right? So one way we could think about h and k here, sure, they mean the same thing. They mean horizontal translation and vertical translation. But for a function like an absolute value function, where the vertex is the point that we're always going to keep track of, right? That's the recognizable point. All the other ones are just parts of lines or rays, right? This is the one that we track. This really represents the coordinates of the vertex, right? So always think of that. H, K is the vertex, right? Those two parameters just tell you the coordinates of the vertex. Now what does A do? Let's say that A for us equals negative 2/3. Do you remember what A does?
Stretches it.
Okay, stretches or compresses vertically, right? And then if it's negative, what does it do?
Reflects over the x-axis.
Reflects over the x-axis. Okay, good. That's still true. But for our function, because our function has straight legs, right? That means that it's easy for us to implement that A. It's really easy for us to do. We don't even really have to think about it as a stretch. Normally, we would go over 1 and up by 1, right? The slope of each leg is 1. Agreed? If we're going to stretch this thing by a factor or compress it by a factor of 2/3, instead of going instead of going over 3 and up 3, we would now go over 3 and up 2, wouldn't we? Right? It's gonna compress it slightly. Okay? But the point I want to make here is just that you don't have to even think of it that way. Just think of this as a slope, right? The slope, instead of being 1, the slope of the right leg of the V is going to be negative 2/3. Now it's negative because it's going to get flipped, right? But watch what we can do here. By creating a slope triangle, we can rise by -2 and run by +3 to get to the next point on the leg, right? That determines the slope of the leg. It's negative, and if I connect those dots, this is what I get, right? It just looks like that. So the other side's going to look like that. Right? That's all it is. A is equal to the slope of the right leg of the V. Okay? So what would it be? What if I did something like this then? Tell me. So if I said h equals 1, k equals -4, a equals 3, how would I draw that thing? What am I going to do to draw my V, my absolute value function? Where am I going to put the vertex? 1, -4, right? So that's going to be the coordinate. The vertex goes at HK, so 1, -4. So I'm gonna go over 1, down 4, right? And how am I gonna draw the right leg of the V? What do I do to get my second point? So A is 3. What does A stand for again? Slope of the right leg, good. Okay, so what is that as a slope? What does that mean in terms of a rise over a run? 3 over 1, yeah. So I'm gonna go from here, I'm gonna go up 3 and over 1, right? And so I'm just gonna connect those 2 points. I'm just gonna go like that, right? And the same thing on the other side, I'll go up 3 and back 1. That's my V. Okay? Everybody see that? All right, let's try a couple. So what about something like this then? They're giving you the function, pretty simple one. What's the value of H, K, and A there? What's the value, Tyler, what's the value of H? It's a little tricky, isn't it? Well, that's the number being subtracted from X, right? If there's nothing there, it's 0, exactly. Because if nothing's there, nothing being there is the same as subtracting 0, right? Okay, so this tells us that the vertex has an X coordinate of 0. What's the Y coordinate going to be? -1, right? Because it's whatever number sits out here, it's plus K. So if it's -1, then we're adding -1. So there's the vertex, okay? What is the slope of the right leg of the V? What's it going to be? -1. Yeah, it's -1 because how come? What number? A is the number that's being multiplied by the absolute value. Well, what does that stand for? If there's a negative in front of something, what does that mean is being multiplied? -1. Good. So we're going to slope of -1. We just have to go find the right one then. Well, that's it right there, isn't it? We got to look at all these choices. That's it right there. It's got the vertex is at 0 minus 1. And look, if I look at the slope here, I rise by -1 and run by 1. If I start at the vertex, that's the slope of the right leg. Everybody agree? Okay. Okay, got it. All right, let's try another one. How about something like that? Actually, real quick, tell me. Okay. Okay, for this one, what's the value of A? -1, so the slope's -1 of the right leg. It's going to open down, isn't it? What's H? 7, very good. Good, not -7, it's 7 because H is the number being subtracted from X, right? Remember, this is the tricky one. H is always going to have a sign that's opposite of that, right? So it's +7. So HK equals 7. What's K? 0, because there's nothing being added or subtracted, right? So 7, 0. We got a slope of -1. Let's find that one. Not quite, right? What's wrong with that one? It's got the right coordinates over 7. It moves. The slope is positive. Good. So that's it right there, isn't it? Okay. Good. Okay, remember on these, I've got these set up, so if you want some extra practice, you can just hit redo the question on the practice tests, and it'll pop up a different one. Okay, I want a different one than that, though. You got to miss it twice, I think, to get a new one. Now I can redo. It's not giving me the one I want. That's okay, but here's what I want. What if real quick, what if I gave you something like this? Ignore that one. What if f of x were, it's real easy, but I just want you to see this. What if f of x were the absolute value of x minus 2? What's A? Not 0. It's 1. Good. How come? This is kind of important to remember in math. It's 1 because if there's nothing in front of something and the numbers are being multiplied, it has to be a 1. That's different than the zeros we got before, right? Think about the special identity numbers for addition and multiplication. The identity number for addition is 0, meaning 0 is the number I could add to something and not change it, right? What's the number I could multiply by something and not change it? 1, right? So if we write something like this, like if I write the line y equals x plus 2, what's the coefficient of x there? 1. Yeah, if nothing shows up, remember there's always an invisible 1 there, right? We don't write it because we don't need to, but it's there, right? So in a case like this, that would tell us that A is 1, okay? All right, let's move on to a harder one. Try this one. Everybody, in your notebooks, see if you can write down these values. I want to know here what's A, H, and K. Okay, let's get I want phones and headphones away and all that stuff, please. Earbuds, phones, please put those all away. Okay, Gage, help me out here. Tell me, what are the coordinates of the vertex? Say it again. No, okay, that's A, right? I want the coordinates, I want H and K, coordinates of the vertex.
5 and 4.
5 and 4, good. So the vertex is at 5, 4. The slope is negative 3/4. Let's find that one. We got to go over 5 and up 4. That looks pretty good right there, right? Over 5 and up 4, let's check the slope. I need to go down 3 and over 4, right? Because my rise over run is negative 3/4. So negative 3, positive 4, it works, doesn't it? Okay, that's it. Oops. There. Okay. Now the next one. Okay, the next few problems on the test are a little different. This time you're working backwards. This time you're being given the function and you'll be given the graph and you have to write the function. So it's the same thing though, isn't it? All we're going to do here is from the graph, you're going to extract the values of A, H, and K and then just plug them into this formula, right? Does that make sense? So we're going to see what A, H, and K are and then plug them into that. Okay? So what do we get there? Looking at that visually, what are the values, Manuel, what are the values of H and K?
I have to think about that.
Okay? Take your time.
Zero.
0. Yeah, 0 and 0, aren't they? Mm-hmm. Yeah, good, because it's at the origin. Good job. Okay. Oh, so, okay, right. So you're not going to, when you simplify, you don't have to put anything in there, do you? So what we're going to see from this, we're going to see that, okay, we see from the picture that H is 0, K is 0. So when we plug it in, they won't be there. What's A? 2. Yeah, because if I start here and we draw a slope triangle, I'm going to rise by 2 and run by 1, right? So A equals rise over run, which is 2. So all I've got to do is just plug that stuff into my template. Now what you might want to do, at least at first, I don't think you have to do this very long, but what you might want to do at first is even maybe just start with the template. So you know your answer is going to look like A times the absolute value of X minus H plus K. Now just plug them in. If I put 0 there on the end, I don't have to put plus 0, right? I can just get rid of it. Same thing here. Minus 0, X minus 0 is just X. Then out front, all I need is a 2. So that's my answer right there. Okay?
We're still working.
What's that?
We're still working.
I kind of hope it doesn't. I kind of hope it tells you it's not simplified, but we'll see. How about? Okay, let's try one. Let's try another one. So that one would just be negative. What is that going to be? 7/4 is A. Everybody agree? If you go down 7 and over 4, so that should be. Get rid of this stuff. Negative. Whoops. Yikes. Well, that's just doing. Okay, here we go. So negative 7/4 absolute value of x. We're going to try -0, right? See if it works. Yeah, see, it won't take that. Yeah, because it's not simplified. Okay, good. I don't want it to.
If we get a fraction that can simplify, we'll just.
Yeah, do. Right, if you can. Okay, what about, I'll tell you what, let's just scoot ahead. We'll do a little harder one. Let me see. Okay, what about that one? What about that one? So what are the values of H and K? Lariah, what's the value of H? So what's the x coordinate of the vertex? -5. Good. Y coordinate? 1. So that's H and K, right? Good. So we got H equals -5, K equals 1. That's good. Only thing we now need are the slope of the right leg of the V, which is, and everybody agree, -1? I start at the vertex, I'm going to rise by -1 and run by +1, so A equals -1/1, which is -1, right? Okay, so let's plug those in. So then our answer needs to look like, I'm going to start with the template again, A times the absolute value x minus H plus K. So K was 1, I can replace the K with a 1. H is -5. Now that looks funny. What do I do there? Hello? Hey. Yes. Okay. Yeah. Okay, I gotta go. Okay, bye. Sorry about that. Okay, so what do I do with a minus and negative? Make it a plus. Yeah, that becomes a plus, and then A was -1. Now I don't want to write it like that. What do I do? Just a negative. Okay, everybody agree? Okay, looks good. Wow, look at that. We're awesome. How about that? Okay. All right, moving on. So that's what the first part of the test is just dealing with absolute value graphs. Okay, now we move on to absolute value equations. Okay, so I'm going to start you off with a really easy one, right? Now, we're shifting gears here. When we're solving an absolute value equation, you want to refer back to this page, right? And all this stuff, by the way, let me show you where this is. I put all this stuff on Moodle, so if you ever want to download any of these resources, they're there. If you just go to Unit 1 Resources, there's everything for you to download, okay? The function transformation rules, there they are. There's the solving absolute value equations and inequalities. That sheet we're just looking at, it's right there. They're PDFs. You can either pull them up online or you can download them and print them out or whatever you want to do. There they are. Okay, so look what this tells us here, right? This is reminding us, and let me again emphasize this. The strategy for solving absolute value stuff, equations or inequalities, is always the same. You can't do algebra without absolute value bars. It doesn't work. It's too complicated. So we always want to make a trade. Don't put that away, please. we always want to trade the absolute value thing, equation or inequality, for two regular things. It's a 2-for-1 deal. Unfortunately, we have two of them instead of one, but they're easy to solve. So it's still a bargain for us. We can't solve this, but if I can get the absolute value by itself on one side of an equation, right? So I can look like this. The absolute value of something is equal to a number, then I make my trade, and I get rid of the absolute value bars. I'm going to rewrite it as whatever's inside the absolute value is equal to C, or whatever's inside is equal to negative C. It's the same way every time, and then I just solve those two equations, right? So let's try that. So what about this one? This is pretty easy. Is the absolute value isolated, first of all? It is. Everybody know what I mean when I say that, right? The absolute value is not being multiplied by anything. Nothing's being added or subtracted to it, right? So it's by itself. So now I can make my trade. What does my trade become? If I've got the absolute value of x equals 15, how do I execute the trade? What do I trade for? What are my equations going to be? Whatever's inside, and just think of it as the blue bubble, whatever's inside is equal to what? 15, or, yeah, whatever's inside, just think of it as the blue bubble, don't even worry about what it is yet, is equal to negative 15. Well, it's just an x, it's an x. So those are our solutions. This one's already done. The answers are 15 and negative 15. So I would just put those numbers separated by a comma, right? Easy. Okay, let's do a harder one. Oops.
So we just put 15, comma.
Yep, I just put in any order, doesn't matter which order, 15, comma, negative 15, just like that. Okay. Let's try a harder one. Oops. Okay, so how about that one? Let's look at that guy. Yeah, okay, I got some stuff to do here, don't I? Okay, so is that absolute value isolated?
No.
It is not. It's not. So, Caitlin, what do I have to do to get the absolute value by itself? What do I have to do? Ariel, what do you think? I want to get that absolute value by itself. At 10. Good. Now, don't be wigged out by the fact that we're trying to isolate something big. Usually we're used to isolating a variable. It's the same process. When I want to isolate something, I'm just going to work backwards through order of operations, right? So whatever I'm trying to isolate, in this case it's that, I'm going to undo stuff in that order. So first thing would be to undo addition or subtraction, just like always. So I add 10 to both sides, and I get then absolute value of 2x plus 4 equals what? Which is what? Negative 6 plus 10 is what? 4. 4. Okay. Is it isolated? Absolute value? It is, isn't it? Yeah, the absolute value is all by itself. There's nothing out front and there's nothing being added or subtracted, right? Okay, so now Maisie, what's my trade going to be? Now that I got to where the absolute value is isolated, now I can make the big trade. I'm gonna shift from absolute value to stuff without absolute values, so I can finish. So what do? So what's inside, remember, I'm just going to get rid of the absolute value bars. So what's inside, yeah, is either going to be equal to 4 or negative 4. Good. So what's inside is that. So I get the two equations. 2x plus 4 equals 4, or 2x plus 4 equals negative 4. Now all I do is what? Solve them. Solve them one at a time, and that's easy, right? Those are simple ones to solve. Okay, so what do I do over here to get the x by itself? Okay, minus 4. So I get 2x equals 0. So what do I do next? Divide by 2. So what's 0 divided by 2? 0. So one solution is x equals 0, right? How about over here? Same thing, right? Subtract 4. Good, I'm going to get 2x equals negative 8. Good, divide by 2. X equals negative 4. So those are my solutions, right? Okay.
You just separate those with a comma.
Separate them with a comma. Yep. Okay, so next. Let's look at this guy. Okay? So what do we do with this? This looks different. It is different. Okay, I want you to think about, see if you can remember what to do with this. Okay, on your notebook, so you try that out. Okay, you can remember what to do. Try this. See if you can remember what to do with this. I gotta make a trade, right? It's an absolute value thing. It's an absolute value inequality, so I gotta make a trade. What's my trade gonna be? Yeah, remember I got it. You guys know what I mean by trade, right? When I say you got to make a trade, I've got to trade the absolute value stuff for non-absolute value stuff. That's my goal. Whenever I do anything with absolute values, that's how I got to work with it. Okay, but I got to do something first. What do I have to do first? I got to subtract 7. Good, because the first step is always I've got to get the absolute value by itself, right? Okay, so we always know we have to do that. So the first step to get this thing isolated, I've got to subtract 7 from both parts. And then I end up with absolute value, of 3x plus 27 is less than or equal to what? 3. Okay, good. All right, but now what? Okay, so now we got to go back to that sheet and see. Oops, there it is. Okay, we got to move down, right? So this is a case where we had an absolute value expression that's less than a number. There's 2 possibilities for absolute value inequalities though, right? Either we're going to get an absolute value that's less than a number or an absolute value that's greater than a number. Each time we're going to make a trade for 2 inequalities, but they look different. Let's start with the bottom one, actually. The normal thing we'd expect is to get an OR, right? Just like we did before. When we solved an absolute value equation, we ended up with an answer, x equals this or x equals that, right? So we split it into 2 equations, and it was an OR statement, one or the other, right? We had to solve them separately. If we have the bottom kind, where an absolute value is greater than a number, we get an OR also, slightly different. This time, instead of setting what's inside equal to C or negative C, what's inside is either going to be greater than C or it's going to be less than negative C, right? Think about it as being extreme here. The absolute values, in order for the absolute value to be greater than C, it's either got to be very big and positive or it's got to be very big and negative, right? So when I take the absolute value, it becomes positive. So it's either going to be greater than C or it's got to be to the left of, more negative than negative C, right? The one that's the weird one is this one. If the absolute value is less than C, then we don't get an OR statement. We get one that's bounded on both ends. Now this is the one. How do you remember which is which? I gave you a little hint. I'll remind you about that. If you want to know which of the 3 is not the OR one, which is the weird one, it's the one that the absolute value points at, right? It points at the one that's an AND. It's not an OR, right? So what do we do with this? Whatever's in the middle of the absolute value bars goes in the middle of the statement, and then the upper limit is C and the lower limit is negative C. And I just solved that, okay? So let's go to our example and try that. Oops, there it is. So we got this, right? We have an absolute value expression that's less than a number, and so the absolute value is pointing at the and one, right? So what am I gonna do then? How am I gonna set up the inequality?
Is greater than
Okay, so what's inside goes in the middle, right? And it's gonna be greater than or equal to the lower limit, which is what?
-3.
-3, and less than or equal to 3. Okay, good. So now what do I do to get the x by itself? Good. Same kinds of steps I would always do, only I'm going to do them to all three parts of this. So we subtract 27, and if I do that, we get -33x and 24. Okay, next step.
Then you
Divide
divide
it. Okay, divide by 3. So when I divide by 3, I'm dividing by a positive, so I don't have to flip around the inequalities, right? Everybody agree? So I'm going to get -10 stays the same, x stays the same, and 8. That's my answer, right?
it. Wait, so wouldn't that be negative 8?
Yeah.
Oh, you're right. Huh, it is -8. Good, thank you. So x is greater than or equal to -10 and less than or equal to -8, and that's exactly how I would input it. Question? Or not?
Yeah, you said that if something was negative, then
Yeah, we'd have to flip it. Let's look at one like that. Okay. So what would happen if, let's see, what would happen if we had one like, no, I want a different one. I'm just going to change that one slightly, okay? So we won't do this one in Moodle, we'll just do this one. I mean, we won't do this one, we'll just do this one on the board. So 4x, 16, 12, all right? So what about this? What if we had, I'll make a tricky one for you. What if we had this? What if we had negative absolute value of 4x plus 16 is less than -12? Okay, a little bit tricky. Do I have to do anything to isolate the absolute values?
No.
I do.
times of
Yeah.
this.
I do. I do, because look at this, right? I'd have to multiply each side by what?
1.
By -1. Change the signs of both sides, right? So I could make both of those positive, but if I multiply or divide by a negative, what do I have to do? I gotta flip the sign, yeah. So that's gonna become that way, right? Now I've got absolute value of 4x plus 16 is greater than positive 12. Okay, what kind of trait is this? Is this and or or? It's or, right? Because it's not pointing at the inequality, so it's regular, it's or. So then I end up with what kind of a trait? What's inside is either going to be two things. Either it's going to be what? It's going to be what, greater than or less than?
Oh,
Doesn't matter what order. Let's just say the greater than. What's going to be greater than? 12. Or it's going to be less than -12. Exactly. Okay, so let's just say hypothetically, I'm going to change this a little bit. Let's say that was a -4x. Okay, pretend that was a -4x in there. So then we end up with a -4x plus 16 is greater than 12, or -4x plus 16 is less than -12. What are the steps I would go through to solve for x there? What do I do? Okay, good. I'm going to subtract 16. Good. Minus 16 from both sides. Those go away. I get -4x is greater than -4. Now what? Okay, divide by what? Okay, I'm gonna make the negative red, because that's crucial. What happens when we divide by a negative? Flip the sign, yeah, we gotta flip the sign. So I always put a circle around it and immediately change it or I'll forget. So I end up with x is greater than -1. Or if I do the same stuff over here, everybody agree I get -4x is less than -28. Divide by -4 means I gotta flip the sign. So I get x is greater than 7. So those are my answers. Okay, one last thing though in Moodle. When I input that, if I wanted to input x is, this is not the answer that's going to be in Moodle, but pretend it is. If I input x is less than -1 or x is greater than 7, here's how I have to do that. I'd have to say x is less than -1, and it tells me to use the OR symbol. So if I go to the operations menu, if I hover over these, it tells me what they are, right? It's that one. Okay, it looks like a V. That means OR.
So you just have to do that when it's like that?
Yep.
Okay.
Yep, you do that one for this kind of inequality, you'd have to include that OR symbol.
Right.
Okay? Good.